Hello guys, in this video I'm gonna explain the basic atomic structure. First of all, before I go on to the atomic structure itself, I would first talk about what an actual atom is. So atom is the smallest working unit of everything. So it's the smallest working unit of matter. So for example, if you have a ball like so, let's draw a wall. This is our really bad wall. Let's just imagine it's a wall. If we have this wall, then we have smaller bricks which combine together to actually create this wall. So we have right now 9 actual bricks which are combining together to form this one wall. So we say these are the bricks are the basic unit of our wall. Just like this, atoms are the basic unit of everything we see around us. Like if we have a metal or a plastic, like a non-metal, they're all different from each other because they are made up of different atoms. These atoms define the actual physical properties and all the other properties, like how much their weight is, their mass is, how rigid they are, how flexible they are. Everything is actually it is the atom itself which defines all these properties. So atom is the most important thing in chemistry and in every science. So we're going to talk about its structure. Before I actually talk about structure, let me just tell you here that if you take an atom and divide it even further, so you have this atom, let's just imagine this is our atom, and you divide it even further, so you divide it into 2 pieces. It's not gonna work properly anymore. It's not going to work anymore. If it was an atom of, let's say, carbon, let's just imagine carbon is an atom. It's an element made up of atoms. So if you imagine this and you divide it into, let's say, 2 pieces, it's not going to work any longer. So atom is the smallest working unit of everything. So let's go on to its actual structure so we can talk about it in more detail. So let's do it now. Now, an atom is made up of 2 main parts which we usually talk about. The first part is called the nucleus. Nucleus. And the second part is called, it's called shells or orbits. So we have shells or orbits. So these are the 2 main parts of any atom. So if you have an atom, you can divide it into further 2 parts. Like you can imagine it into further 2 parts. Like you can see in this atom here, it's an atom of carbon. You have this middle part here which contains some random dots which you're gonna come up to, and it has some circles around it. It's just like a solar system where you have sun in the middle, and then you have different orbits in which, like, our Earth and all other planets are orbiting. So these are the 2 main parts of any atom. Now we're going to talk about nucleus first. So guys, nucleus of an atom. Now we're going to talk about nucleus of an atom in more detail, so we have an idea about its structure. First of all, let's just imagine, let's draw the nucleus first. If I can find how to do it. Yeah. So we have this central space within an atom. So if you could imagine an atom as like a football, then you will have a small tiny place within that football, like the size of a golf ball, even though it's much tinier. But let's just for the purpose of our imagination, just imagine that this is a space within the atom which is called nucleus. It's a really small space compared to the actual size of the atom, which is immensely bigger than the size of the actual atom. So the nucleus is made up of 2 subatomic particles. Now this is a special word you need to learn for your exams. Subatomic particles. Now these are particles which exist within an atom. So these are also like, you can imagine them as particles. They are particles, but they are so tiny, tinier than the actual atom. Now atom itself is so tiny that if you imagine yourself, or actually even smaller thing like a golf ball, and you start dividing it into a billion parts, so you chop it down into billion parts, that one in a billion part is an atom. That's how immensely small an atom is. Now if you go further down into the atom, now this is even smaller. Subatomic particles are so small that we call them subatomic particles. Now there are two subatomic particles which exist within the nucleus. Even though there are three in total, two are found inside the nucleus. One is called proton, and the other one has been neutron. So you have, neutron here. So now these are the two main particles which are found inside the nucleus of an atom. Let me just label this whole thing here as being the nucleus. Now in real life, nucleus doesn't have this line boundary. Like I've drawn it here as a circle, but it's a 3D sphere like thing, but it doesn't actually have a boundary, like physical boundary. It's just for our imagination purpose that I've actually drawn it as being this. But if you look at it in the other ones I did, this one, look here, you can actually see there is no like a boundary around it. They're just two particles within and some outside. But let's, for the purpose of our video, imagine this is the nucleus, so it's clearer to see. Now we can draw our two subatomic particles within the nucleus. Now I'm gonna draw two of each. So I'm gonna have two of each. Okay, let's put plus in one of them. Okay, and the other one is well, I'll just put n inside the other one, n, even though it's not the actual sign. Now the one with plus in it is our proton, and the one with n in it is our neutron. The reason why I've labeled proton as plus is because it has the reason I've labeled it as being positive, like a plus sign, is because the protons themselves are positively charged. Now if you don't know what a charge is, I'm gonna explain it in a minute. So let's just for the purpose of it, let me just write down what it actually is. It has a +1 charge. So protons have a +1 charge. Now let me just explain what charge is for a short term. Now there are two types of main charges. One is plus and the other one being minus. Now if you have two of the same type of charges, let's say you have two of pluses or two of negatives, one is plus and the other one is negative, they will repel each other. But if you have two opposite charges, they will attract each other. So within the nucleus you have these protons which have positive charge, and each proton has a +1 charge. So each proton has a +1 charge. And let's talk about neutron as well. They have no charge. That's why I couldn't label it with actual charge. There is only two type of charge. One is positive, one is negative, but the nucleus overall has only positive charge because of the protons. So neutrons have 0 charge, so they are called electrically, so we can say they are electrically neutral. So 0 charge, so they are electrically neutral. And these are the electrical properties of both particles. Now let's talk about another property of these, which is a bit like obvious one, which is whenever you have an object and you try to it has a mass. Every object on earth, like most of the objects on earth, have mass. If you have a plastic bag, even though its mass is really tiny, like compared relative to us, it still has a mass. The mass of anything comes from the protons and neutrons. So let's talk about this. A proton has a mass of 1. Mass of 1. Now when I say mass of 1, I don't mean mass of 1 in terms of grams or kilograms. I mean in terms of unified atomic mass unit. Unified atomic mass unit. Let me just write it. Unified atomic mass unit. You don't need to learn it for the purpose of GCSE. If you are watching this video for GCSE, it's just me explaining a bit more to make it clearer. This is a mass unit because the mass of an atom is so tiny. It's something like a billionth of a gram. So it's immensely tiny. You can't actually measure. If you start to measure it using the normal scales and the normal values, it would be so tiny that it would be immensely hard to actually do all the calculations on the atoms and in chemistry. So what they've done, they have come up with the smaller unit of mass, which is at atomic level, subatomic level. So a unified atomic mass is used at very low level. And if you are interested in this, you can watch my other video on unified atomic mass. For now, I'm just gonna carry on with our actual structure of an atom. So this has a mass of 1. You just accept that it has a mass of 1, which is really tiny. And let's do for neutrons. Now neutrons also have a mass of 1. They have this property in common. They both have a mass of 1. Now these two particles have the same mass. They have a mass of 1, but one of them, proton, has a charge of +1, whereas the neutrons have 0 charge. So this is the basic structure of a nucleus. Now there are two terms which are related to the atom at intermediate level of chemistry and GCSE, which are atomic number, which we can also called the proton number. And we have, I don't have enough space, so I'm just gonna carry on wherever I can find some space to explain things, or I might just start a new slide. Might be easier. And we have a mass number. Now mass number is just mass number. So let me just talk a little bit more about these two terms. One is atomic mass or proton number. The other one is mass number. Now what is an atomic number? It's simply the number of protons inside the nucleus of an atom. So you just literally count how many protons are there inside the nucleus. There are 2 in our case, so the atomic number for this one would be, let me just write it down, atomic number for our specific atom, this nucleus or atom which we have drawn here, is 2. So we have atomic number. So our nucleus has a atomic number of 2 because it has 2 protons. You can count it 1, 2. We have 2 protons, so we call it. It has an atomic number of 2. Now let's talk about mass number. Now mass number is the actual total mass of a nucleus yeah. So if you want to know the mass number of an atom or a nucleus, in our case, because it's actual nucleus which gives an atom is these two properties, atomic number and mass number. So if you want to know the mass number of an atom, you just count the number of protons and neutrons in its nucleus, because they both have a mass of 1, and the total mass of an atom comes from these two particles. So we're gonna count how many protons and neutrons there are in this atom, and these are 1, 2, 3, 4. So we say it has a mass number of 4. So the mass number for this one, sorry, it's just gone too small, I don't know why. So it has a mass number of 4, sorry for the small form. Yep. So these are the main properties of our nucleus which you need to know for the purpose of GCSE and for intermediate level chemistry. There are other terms related to an atom like isotopes, which come under this. Isotopes are different atoms of the same element with different number of neutrons. I'm gonna make a video on that, so if you want to look it up, just type isotopes. For now, let me just tell you what's important about the atomic number and atom itself. When you atomic number is really important. Atomic number for any atom doesn't change. So if you have a, let's say, oxygen atom, oxygen like found in the air, you will have atomic number which is fixed. It never changes. If you change this atomic number, the whole properties of the atom will change. It's going to turn into a different atom. It won't no longer will be oxygen. It will turn into carbon, hydrogen, or any other element. So atomic number defines the actual element. So it never changes. It stays the same for a certain element. So this is our atomic number. Whereas the mass number, so you could have a same atom of oxygen with let's say 8 neutrons, and then you could have another one with 9 neutrons. They are still the oxygen because the atomic number or the number of protons in the nucleus hasn't changed, but they are different isotopes of the of our oxygen atom. Now we're going to talk about the second part of our atomic structure, which is shells or orbits. Now shells, or what we call orbits, are found around the nucleus of an atom. So if we draw our nucleus again, here, this is our now the nucleus compared to the actual number of shells is really tiny. So this is our nucleus, which I am gonna just put a color in so it's easier to distinguish. Sorry for this. So this is our actual nucleus. So this is our nucleus. Now we're gonna have some shells around it. Now what our shells look like, let's have our shells around the nucleus. Let's just draw 3. Whoa, that's gone wrong. That's gone wrong. Wait 1 second. So guys, I've drawn a new one where I've shown our nucleus as being yellow, so it looks like a bit like sun and our solar system, which is a good analogy in this case. So we have these shells, and what the function of these shells is, as I mentioned before, there is a third subatomic particle which is called electron. Now this is important in terms of its chemistry and the chemical reactions, because that's what actually determines any reaction. Protons and neutrons in any atom stay the same, they never change. Anything inside the nucleus stays the same. It's the actual electrons inside the shells which actually cause a reaction to occur. Now electrons are found in these shells. Now the first shell can have up to 2 electrons. Now you can either label them as being this, or you can label them more interesting way and better way, which is E minus. Now I'm drawing them in pairs because that's the usual way to do it, but it doesn't matter how you draw them for this level, so just draw them anywhere and run as long as they're in the specific shells or orbits. Now notice I have 2 electrons in my first shell and I have 8 in my second shell. For intermediate level and GCSE students, this is the basic method. The first shell can occupy up to maximum of 2 electrons, and the second and third and so on can occupy up to 8 electrons, and they actually need that many electrons to become stable. Any atom which doesn't have 2 in the first one, or 8 in case of any other shell, will try to gain that many electrons by either taking them away from other atoms or giving its own electrons away. This is a way of them gaining stability. So this is what actually causes the reactions to occur. So we have the electrons, and now let's write down the properties of electrons. Electrons, notice the minus sign, have charge of -1. So they all have a charge of -1. So we talked about positive charge for protons. Now these have negative charge. So obviously these are attracted towards the positive protons within the nucleus, which keeps them stable and in their orbits, just like gravity pulling all the planets towards sun. Just like this, we have these electrons orbiting the nucleus, which has a positive charge. So nucleus itself has a positive charge due to protons, and these are the negative electrons which are actually within the shells around the nucleus. Now these electrons, just like our protons and neutrons, now when we talk about their mass, the mass is neglectable. It's so tiny compared to the mass of our protons and neutrons. Their mass compared to the mass of our proton and neutron is something like 1/2000, if you want to make it easier for the purpose of GCSE students, in case they call is thought to be 1/2000 mass of a proton or neutron. Now this is immensely small, so we don't usually give it that much importance, and we just usually just ignore it. So we have these electrons in the shells, and which have a negative charge, which is really important, and they have a mass which is really tiny, so it's not important. You can just ignore it. So this is our basic structure of an atom. It has electrons inside the shells, which can move, which can be transferred from the atom to other atoms, and which obviously changes its balance of charges. Like if it has excessive electrons, it has a more negative charge, or if it loses electrons, then it becomes more positively charged, and this is called they are called ions, not atoms, and I've made a separate video on that, so if you want to watch it. For now I'm just gonna go back to our basic structure. So if I bring our basic structure back here, basic structure back here, let's just make it a bit bigger. So this is a carbon atom. Carbon atom is carbon atom because it has an atomic number of 6 and it has a mass number of 12. So it has 6 protons and 6 neutrons, and these are the electrons outside in the shells. So these are the 3 subatomic particles, and one more important thing is the valence shells. The outer shell, the very outer shell, is called valence shell. Valence or outer shell is called outer shell, and the electrons which are found within that shell are called valence electrons. Now this is important for GCSE students to learn. They are called valence electrons. They are found inside in the outer shell. Yeah, so pretty much this is the basic structure of an atom. If you want to know more, then I'm gonna put some links in underneath the video. You can carry on with them and learn more about the structure of an atom, and more all other sorts of things which are related to the atomic structure. So thanks for watching the video, guys, and I'll see you in the next video. Bye.